The idea that citrus fruit peels serve as potent reservoirs of vitamin C and flavonoids is well supported by a growing body of scientific evidence. When we examine citrus varieties such as oranges, lemons, and grapefruits, not only iconic for their flavor, but also historically revered for their scurvy-preventing abilities, we find that the nutritional spotlight has long been placed on the juicy pulp. However, a closer biochemical inspection of their peels reveals that the outer layers contain a far denser concentration of health-promoting compounds than previously acknowledged. These findings shift the perspective on citrus peels from being mere byproducts to becoming valuable, underutilized sources of nutritional and therapeutic compounds. Vitamin C, or ascorbic acid, is one of the most abundant water-soluble antioxidants found in citrus fruits. Yet when comparing flesh to peel, it becomes clear that the peel holds a significant edge. For instance, data indicate that orange peels contain up to 110.4 milligrams of vitamin C per 100 grams, substantially higher than the pulp, which typically averages around 50 milligrams per 100 grams. Lemon and grapefruit peels demonstrate similar trends, with their ascorbic acid content often doubling or even tripling that of the flesh. This is consistent with the plant's evolutionary need to protect its vulnerable interior from oxidative stress and microbial invasion. The outer layers serve as biochemical shields and thus accumulate more antioxidants, especially ascorbic acid. Beyond vitamin C, citrus peels are treasure troves of polyphenol and flavonoids, particularly flavonones such as hesperidin, naringin, and areocitrin. Orange peels contain roughly 83.3 milligrams of flavonoid content per gram when measured in catechin equivalents, a staggering figure compared to the trace levels found in juice. Grapefruit peels are especially rich in naringin, which is responsible for the fruit's characteristic bitterness and exerts cholesterol-lowering, anti-inflammatory, and anti-carcinogenic effects. Lemon peels contribute high levels of rutin and areocitrin, both linked to vascular protection and blood sugar regulation. These phytochemicals are often concentrated in the flavido, the colorful outer layer, and albedo, the white spongy inner peel, which together comprise a significant portion of the fruit's antioxidant activity. The fiber content in citrus peels also surpasses that of the flesh, with a higher ratio of insoluble to soluble fiber. This property not only improves gastrointestinal motility, but also acts as a prebiotic, nurturing beneficial gut microbiota. In modern nutrition science, the integration of high-fiber, antioxidant-rich peels into daily food intake is being explored as a promising strategy for chronic disease prevention and metabolic health. The practical applications of citrus peel-derived compounds in food science are expanding rapidly. Their potent antioxidant activity, driven by synergistic interactions between vitamin C and flavonoids, has made them ideal candidates for natural preservation in food products. Extracts from citrus peels are already used in extending the shelf life of oils, meats, and baked goods, reducing the need for synthetic preservatives. In functional foods, powdered citrus peel is being added to teas, protein bars, and smoothies to enhance both nutritional content and flavor complexity. Supplement manufacturers have also taken note, with concentrated citrus peel extracts appearing in capsules and powders marketed for immune support, detoxification, and cardiovascular health. These supplements often include standardized levels of hesperidin or naringin to ensure consistent therapeutic effects. Additionally, limonoids found in peels, though bitter, have shown chemopreventive and liver-supporting properties and are being studied for integration into nutraceutical formulations. From an ecological and economic standpoint, utilizing citrus peels also aligns with sustainable food systems. Millions of tons of citrus waste are generated globally from juice production alone. Transforming this biomass into valuable health products and functional additives not only reduces waste, but also adds economic value to what would otherwise be discarded. This circular approach to nutrition, leveraging what nature already concentrates in abundance, offers a model for future innovation in both public health and food technology. In summary, citrus peels far outperform the pulp in concentrations of vitamin C, flavonoids, and dietary fiber. Their biochemical richness lends them powerful antioxidant, anti-inflammatory, and potentially chemoprotective properties that are just beginning to be fully appreciated. As research and commercial applications expand, citrus peels are emerging as functional ingredients with immense potential in health promotion, food preservation, and sustainable product development. These once overlooked fruit components are now poised to become a cornerstone in the next generation of functional nutrition.